Assalamu alaikum and good day, everyone. On behalf of Global Center for Innovative Systems and Solutions, abbreviated as CISS Global ITU chapter, we welcome you all the participants who joined us from different parts of the world. They will keep joining with the passage of time, including US, Pakistan, China, Italy, Hungary, etc. With the slogan of science and education beyond religious and territorial boundaries, CISS Global is a consortium of R&D labs from across the globe that are committed to join hands for STEM and STEAM innovations, knowledge dissemination, and education outreach to make a significant impact in science and society. Uh, to continue our vision, we continue to organize various talks, seminars, so on and so forth for the knowledge dissemination purpose. For that reason, today we thank Dr. Muhammad Rizwan for accepting our invitation for an invited talk and joined us as a speaker. Dr. Rizwan is currently serving as an assistant professor at the Department of Biomedical Engineering at Southwestern Medical Center, University of Texas, USA. He received his master's degree from Seoul National University, South Korea, and his Ph.D. Was from my alma mater, National University of Singapore. We worked together there. After PhD, he moved to Canada, where he worked as a postdoctoral fellow at University of Waterloo. He's a currently as he's assistant professor and principal investigator of Rizwan Lab. His research interests include biomaterials, hydrogel, tissue engineering, and regenerative medicine. I personally have a long-standing ties with him as a close friend, and we are really eager to convert this friendship into an effective collaboration as well. The title of his talk is Engineered Biomaterials to Advance Tissue Regeneration. With this, we really thank you, Dr. Rizwan, for sparing time for us. Now, stage is yours. Thank you so much.
Well, thank you so much for the kind introduction, Dr. Qasim. It's wonderful to be here and to present our research. Are you able to see my screen?
Yes, sir. Yes.
Okay, so let me go full screen. Okay, great. And I changed my slide. Are you able to see?
Yes, sir.
Okay, great. Because sometimes it doesn't work, so I want to make sure that it's working. Well, thank you again for inviting me. As Dr. Qasim mentioned, I graduated from Singapore with a PhD in biomedical engineering, and then I moved to Canada to do my postdoc, first in University of Waterloo, and then in University of Toronto. Currently, my lab focuses on development of biomaterials for tissue engineering applications. And I am associated with both Department of Biomedical Engineering as well as the Department of Ophthalmology at the University of Texas, Southwestern Medical Center. So I do understand the challenge of presenting here because the audience may not necessarily be in the field of biomedical engineering or tissue engineering. So I'll try to make it easy. I'll skip some of the slides that I'll think is too much for this audience. But let's see how this goes. Okay, so UT Southwestern may not be very well known in Pakistan, particularly because it focuses on healthcare research mainly, and it's a medical center. So currently, basically, this picture I think beautifully shows the campus. So all of basically these buildings here, if you're able to see my pointer, this is 2 of the 4 campuses of University of Texas, Southwestern Medical Center. And in the backdrop, you can see the skyline that is the Dallas here. So we are about 10 minutes drive from Dallas downtown here. Okay, so it's a wonderful place to do research, which is pretty evident from what we are seeing on this slide. So this is a Nature Index rankings of different institutions across the world in the area of healthcare. And University of Texas Southwestern Medical Center is right up there in the top few institutions in the world, and particularly in the area of healthcare research. So Recently, the reason I moved, or the reason that they recruited me from Michigan, previously I initiated my lab in Michigan Technological University, and I recently moved to UT Southwestern just a few months ago. They had actually initiated this Department of Biomedical Engineering, which is awesome. Like this was intriguing because a medical center with an engineering department, this is not something that's very common. And their idea was that having a biomedical engineering department will allow researchers with an engineering mindset and engineering background to collaborate with clinicians and physicians who are working in a medical center. And this way, there will be more translational research that can be carried out. So they initiated this joint effort between UT Southwestern University of Texas at Dallas, and built this brand new building. And this is where basically we have set up our lab in the UT Southwestern. Okay. So what do we do? Well, simply put, we develop biomaterials. Now, when we think of biomaterials, biomaterials can mean a lot of things. The type of biomaterials that we develop are these really soft, jelly-like biomaterials. We call them engineered hydrogels. Hydrogels because they mostly contain water. And this is why we are interested in these biomaterials, because these biomaterials have a lot of water. That's why they mimic tissue properties. And we want to grow tissues inside these biomaterials. So how I'm using my material science background is that we try to leverage the engineering principles and material science approaches to create these hydrophilic networks, and then we try to modify the properties of these hydrogels. For example, we can make them stimuli responsive so that they can respond to the external light, and those light exposures can either degrade or improve the properties of these hydrogels. We can also encapsulate drugs in these biomaterials and release those drugs by tuning the meshwork or the architecture or the molecular composition of these biomaterials. We can improve the types of cross-linking that we are using so that when we put cells in these biomaterials, cells are able to grow and to rearrange these matrices to perform their functions. We can also, for example, put signaling proteins inside these materials so that we can direct the differentiation of stem cells. So there are a ton of things that we can do by engineering these hydrogel-based biomaterials.